Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. Good morning.
So before we start, I just want to clarify one thing.
Yeah.
Today and in the test, COM only till center of mass is there, right? Collisions is not there, no?
Right.
Okay.
And what are the timings of the test?
I don't know. You're asking the wrong guy.
सर क्योंकि कोई मैसेज भी नहीं आया है कि टेस्ट है
Hey,
साइड पे भी नहीं दिख रहा है कि कोई
सर
अपकमिंग
साइट
टेस्ट
पे
है।
भी नहीं दिख रहा है इसलिए
एक सेकंड रुको तो कंफर्म करना है. Are you people able to hear me?
Yes, sir.
Yes, sir.
Evening 6 to 9 will be the practice test. Okay.
Okay, sir.
Fine.
Sir, is it of 1 hour or 3 hours? 6 to 9 is the window.
हाँ तीनों सब्जेक्ट्स का है मैथ्स फिजिक्स केमिस्ट्री.
तीनों सब्जेक्ट क्या है? बताया नहीं था
सर हार्ट अटैक दे रहे हो आप
सर, हमने तो सिर्फ फिजिक्स का मांगा था, बाकी सबने अपना अपना रखा है।
तो रुको कंफर्म कर लेता हूँ. मैं इनको बता देता हूँ कि सिर्फ फिजिक्स का रखने का. तो रुको.
मैथ्स ट्यूसडे
Yes,
को
sir.
ले रहे हैं और केमिस्ट्री सर ने बोला नेक्स्ट वीक में ही टेक।
हाँ
रुको. Six to 9 window will be open. It will be only physics paper. Paper
Okay,
one.
sir. Okay, sir. Thank you.
Okay, sir.
Now, we were discussing assignment 3. We have completed variable mass.
Yes.
Yes, sir.
Yes, sir.
No, somebody is asking, is it today or Sunday? Practice paper is today. Sunday's test is topic-wise test on center of mass.
Yes, sir.
Today it is a 2-hour paper or a 3-hour paper?
Pardon?
It is a 2-hour paper or a 3-hour paper, because you said paper 1, paper 2. Now
1 hour, 1 hour, 2 hours ka paper.
Two paper.
Paper 1,
Okay, sir.
paper 2.
Each of 1 hour.
1,
no?
paper 2, physics.
हाँ,
Right? It is just for practice. अब किसी भी time किसी भी तरह दे दो. Right?
Okay, sir.
Yes,
Yes,
Yes.
sir. Thank you.
It will be open between 6 to 9. Either start at 6 and finish at 8, or start at 7 and finish at 9. Right?
Yes, sir.
Yes.
Sir, the new
Subject.
website does not show any analysis or rank.
yes, sir.
It shows.
In mobile
We
it
have
shows.
communicated this to the tech team. There
The
were
rank it shows.
Sir,
I-
one.
to today's practice test or tomorrow's topic wise test, they said they will incorporate it. Let us see. The maximum I can do is wait. I have communicated to them in clear language and tough language. बहुत दिन से ये चल रहा है यार, टेक टीम कर क्या रहा है, बैठ के कुछ नया डिजाइन कर रहे हो, उसमें 1000 मिस्टेक्स होते हैं कि दे यू फील द प्रीवियस वन इज बेटर.
सर प्लस लेआउट इतना कंफ्यूजिंग है, कुछ समझ ही नहीं आता कि रैंक कहीं और है, मार्क्स कहीं और है.
I told them this. Layout is somehow overall the students are not happy with it. They say even Panisha is better if they give the results immediately.
Yes,
यस
sir.
सर.
Sir,
Right.
मैंने.
I told them let
डाला
us hope for the best. I directly will not be able to do anything. I'll have to put pressure on them, which I am doing. As far as maintaining pressure on them, you can bank on. How
Thank
well
you,
the
sir.
result will come out, let's see. Tomorrow's topic wise test will get to know.
सर और वो मतलब वो क्वेश्चन वाइज एनालिसिस भी होगा ना, अटेम्प्टेड अनअटेम्प्टेड मतलब.
होना है, that's a must, without which analysis report does not make sense.
सर
यस
वो
सर,
मिल ही नहीं रहा कहीं साइट पे.
करेक्ट परसेंटेज.
Okay, I'll again get in touch with them today after the class. Let's see how best we can work out with them. Now assignment 3 में, 1 second. Assignment 3 में, which I discussed with you people the other day.
सब
एक
50
correction है, एक correction है, ध्यान से सुनिए. रुको एक मिनट, assignment खोलने दो. I'll share the screen with you people. The 9th question, which you are able to see on the screen. 9th question, which you are able to see on the screen. That day we discussed this as well.
Yes, sir.
And we
Yes, sir.
committed one very small silly mistake, which they actually laid as a trap, and somehow it slipped off my mind. Right, 9th question, left side column mein, he is asking for magnitude of A, minimum magnitude of velocity of A. तो हमने क्या किया है वहां? What we did is minimum magnitude जब बोला है, this is A or B, which is this one?
A.
This is A. So velocity of A with respect to center of mass plus velocity of center of mass with respect to ground, velocity of A with respect to ground. When this is velocity of center of mass, when this is maximum in this direction, the difference will be minimum. But then you will get minus V naught. You will get this to be, see, this is 2 V naught initially. Somewhere down the lane, right, it will come to rest. This is 2 V naught with respect to center of mass.
Yes, sir.
Yes, sir.
So this is V naught. So when it comes to rest, 0 minus V naught, I will get V naught towards the left. But that will not be the minimum magnitude, it will be the minimum velocity. Minus V naught is minimum velocity. ध्यान से सुनिए. Magnitude of VA with respect to the ground, जब minimum पूछ रहे हो तो 0 होगा ना यार. When it reaches V naught here, with respect to ground, 0 will be the minimum value. Because he is asking for magnitude. He is asking for speed. If I ask you what is the minimum speed it will acquire 0 somewhere in between.
Yes, sir.
2 V naught say it is reaching 0 with respect to center of mass. When it is going, it will acquire a velocity V naught with respect to center of mass. With respect to ground, that instant velocity will become
0.
minimum speed pucha hua hai. He put a mod symbol for that. Do you get this point? We reported
sir.
minus V naught. Minus V naught is not the minimum speed. If you take velocity, it will be minimum. उसमें mod लगा है, so 0 will be the minimum value. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Is this point clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
So one more doubt.
हाँ.
सर 43rd क्वेश्चन आपने सॉल्व किया था सर, उसमें आपको 0 आ रहा था बट आंसर सी दिया है.
नहीं, वहां एक छोटी सी गड़बड़ है. 43rd में 3 and 0 are the answers. They gave 3 while answer is 0. They interchanged the velocities of A and B.
Okay, sir.
I'm coming to that. What you are getting is they have velocity of A when B has maximum velocity. 43rd. This is maximum compression. When you release it, this is A, this is B. They ask velocity of A when B has maximum velocity. B will have V maximum. This will be 3, this will be 0. They gave the reverse. They reported the answer as 3, while the answer should be 0. The answers are 3 and 0. They put the reverse. VA and VB, they interchanged in the answers. So the key need to be corrected for 43rd. Our answer is 0 because they asked for velocity of A. Make the correction for 43rd as well. Subjective में last question also there is a correction and it's an important correction. Can I start the discussion from the last question of the subjective?
Yes, sir.
Yes, sir.
Questions were left of objective.
I know, इसलिए I'll come from last because there is a
Okay.
correction in the last question. Attempt किया है कि नहीं last subjective question?
Yes, sir.
Yes, sir. Third
Yeah.
part में अलग आ रहा है.
तो रुको, आंसर गलत दिया हुआ है वहां. लास्ट ईयर मैंने वो करेक्शन किया भी था मगर somehow it didn't get saved. It is my mistake. 61st question ध्यान से सुनिए. There is a concept also which you need to know. First 2 bits I believe many of you might have solved. This is A, this is B, this is 3L. Right? You gave this the velocity of U. Masses कितना दिया हुआ है?
2m and m. B is
This is M, this is 2M. Right? This U initially will be in these 2 directions. I wish I take the values of theta, theta, theta. Where are my values? 1 second. Yeah. I'll take this as theta. This will be 90 minus theta. So this will be theta. So u cos theta will remain with this. This is u sin theta. Right? You will conserve linear. First question, find the speed of ball A and B just after the string is taut. Right? Just before the string is taut, the velocity along this direction is 2m into u sin theta plus m into 0 is equal to 3m into v. V will be equal to 2 by 3 u sin theta. 2 by 3 u sin theta along this. On substituting the value of sin theta, I'll get this to be 8 u by 15. Do you all agree with this?
Yes, sir.
Yes, sir.
And this will be 3u by 15. 3u by 15. Now I will draw it in a box. See, this mass is m. This mass is 2m. Center of mass ka distance. Will somebody help me out with this value? This will be 5L by 3. And this will be 10L by 3. This velocity I will show in red. ऐसा कैसा split कर दिया? Center of mass is not at half the length. This mass is 2m, this mass is m. ये center of mass क्यों calculate कर रहे हो यार? समझ में आ जाएगा. पहले this velocity you are telling me is 8u by 15. This velocity is 3u by 15. Am I right? Till here is every information clear?
Yes, sir.
Yes, sir.
I will have to rub the left part of the board to solve that problem further. Take it down, please. And second bit me is asking for impulse. T delta T will be final velocity of 2m, initial velocity of 2m along the length of the string. Or put this T delta T. Either way it will do. T delta T is equal to m into v. V is 8u by 15. This is m into 8u by 15. Impulse in the string will be 8mu by 15.
Yes, sir. Done.
Now, first two bits are reasonably easy, no big deal. Many of you might have solved this. Our problem is finding out tension in this over the time in steady state. This tension is what is required. Now, what students commit as a mistake is they say tension provides the required centripetal force. They're right till there. Nothing wrong in that concept. Tension provides the centripetal force, but I don't know the radius. Tension provides the required centripetal force. I don't know the radius. How do you assume that it is rotating about center of mass? If you take a peg fixed here and you tell me you gave a velocity, here tension provides tension minus mg cos theta provides the required centripetal force. It makes sense because I know the radius. Radius is L. This point is fixed. Here, which point is fixed? Center of mass is also moving. Find out the velocity of center of mass. M into 0 plus 2m into 3u by 15 divided by 3m. velocity of center of mass will be 2u by 15. Am I right?
Yes, sir.
Yes, sir.
That part of the board is visible.
Yes, sir.
Yes, sir.
Now, why did you calculate the velocity of center of mass in that direction here? In this direction, I'm not interested in the velocity of center of mass for reasons that you will understand. If you know this velocity with respect to this particular point, then length of the string is the radius.
Yes, sir.
Now what I will do is I'll find out the velocity of this with respect to center of mass. And then I'll tell you tension provides the required centripetal force. Right?
Yes, sir.
This particle they called as A, this particle they called as B. Am I right? Tension will be M, velocity of B with respect to center of mass whole square by 5L by 3. This point is the key catch. I can take this to be the radius only if I know the velocity of B with respect to center of mass. Concept of relative velocity is describing the motion of B with respect to center of mass is at rest. Suppose you are standing on the center of mass, you should know what is the velocity with which this is moving. Right? So if you calculate velocity of B with respect to center of mass, by the way, mass of B is 2m. Small silly mistakes will be costly. 2m is the mass of B. Velocity of B with respect to center of mass is 3u by 5 minus 2u by ये 15 कहाँ से आ गया यार?
Sir, 15.
ये 15 है कि 5?
Sir, 15 है.
15 है सर
15 years.
3u by 15 minus 2u by 15 whole square by 5L by 3. Radius आपने distance of this point from the center of mass ले लिया यार. हाँ, you are describing the motion with respect to center of mass. So you will take that to be the radius. Right?
Yes, sir.
I know the radius. Only if you are describing the motion. Why? What was the necessity for you to convert the problem with respect to center of mass? मुझे radius पता नहीं है unless you tell me you are describing the motion with respect to center of mass. This will be 2n u by 15 whole square by 5L by 3. What am I doing here? Two people also not seeing. Somewhere down the line I'm going wrong with the values. क्या कर रहे हो? How much is the value? क्या करते हो? तो u by 5.
So how that 3u by 15k?
अभी तक सो रहे थे आप लोग. Velocity of B with respect to center of mass. First you found out velocity of center of mass.
That is v sin theta, no?
हाँ.
Yes, sir.
How much is the velocity of center of mass that you are getting?
It should be 3u by 5, right? For v sin theta. Or 15k in the
3u by 5. Here 8u by
15.
15. 8u by 15 is correct?
Yes, sir.
Right. This is 3u by 5 here. Now velocity of center of mass will be how much? 2m
2u by
into 3u by 5 divided by 3m plus 0. Right? This will become 3 will go 2u by 5. Right? This was 3u by 5 and not 15. Please make the correction. So now velocity of center of mass you get as 2u by 5. Till here, is it clear to all?
Yes, sir.
Yes, sir.
Now, bottom line once again, you are hitting the same point 2m. Why are you taking velocity of B with respect to center of mass? 3u by 5 minus 2u by 5 whole square. Because only then I will know the radius of this circular track with respect to center of mass. Radius is 5L by 3. This point, is it clear to all?
Yes, sir.
Yes, sir.
2m into u by 5 whole square by 5L by 3. 6mu square by 25 into 5 is 125. This is the tension acting on this particular string. You can cross verify by verifying tension here. If I try to calculate tension there, m, velocity of A with respect to center of mass whole square by 10L by 3. If I calculate the tension here, velocity of A with respect to center of mass divided by the radius, m, velocity of A with respect to
Minus
center
2
of
into
mass,
5.
tangential velocity 0 minus 2u by 5 whole square by 10L by 3. You should be getting the same answer. Key catch in the problem is realizing that you will have to find out the velocity with respect to center of mass. That's the key catch in whole of this problem. What was the necessity for you to introduce center of mass? I don't know the radius in which it is going about in a circular track. Now students may ask, can I solve with respect to A? Take another point. With respect to A also it is going. You're welcome. एक ही दिक्कत है. A is accelerating, right? Why did you select center of mass?
Not accelerating frame of inertial frame.
Inertial frame. If it is accelerating, pseudo force डालना जरूरी है. That adds to one more variable. So I'll always be on the safe side if I take the center of mass. We don't even know 100% if A is accelerating tangentially or not. So don't take that risk. Can I rub the board?
Yes, sir.
No. Question number 68. They called this body A, they called this body B, they called this body C. A is M1, this is M2, this is M2, this is M2. Now they gave an impulse of J to it. They gave an impulse of J to it. I will call the impulse in this string JA, impulse in this string JB. Agreed?
Yes,
Yes,
sir.
sir.
Theta is 45 degrees. Just after you give the impulse, velocity of this is A. My first equation is J minus JA is M1 into V. First equation, are you people okay with it?
Yes, sir. Yes, sir.
Second equation, I'll take X and Y axis this way for the body. Intentionally I'm doing it. You gave me this angle as 45 degree. So this will be JB cos 45. So JA minus JB cos 45 is equal to M2 into, see this and this, I'll not introduce a new variable. These both should have the same velocity along the length of the string. I'll call it VA.
Yes, sir.
A minus JB cos 45. This mass of M2 should have the same velocity as that of A along the length of the string. So this will also have VA velocity along this length. I call this VA. This angle is 45. Velocity of this along the length of the string should be VA. This equation, is it clear to all?
Yes, sir.
Yes, sir.
Now this will be, this is JB. JB sin 45, JB sin 45 will be equal to M2 into VB along x-axis. VB along x-axis. I'll call this VB along x-axis. Now, why didn't you take JA in this direction? Component of JA in this direction is 0. So I took JB sin 45 is M2 into VBX. Is this equation clear?
Yes, sir. Yes, sir.
Now here JB is equal to M3 into VC. This JB I substitute here and here. I'll be eliminating that. I'll have only 3 equations. This JB I substitute here and here. I'll be eliminating that. I have only 3 equations. But there's one more thing I have to do. VA is equal to VA. You already applied the constraint relation to this string. Yes or no?
Yes, sir. Yes,
Yes,
sir.
sir.
Now apply the constraint relation to this string. Have a look at it. VB, you are taking this as VA. You are taking this as VBX. You know this angle is 45 degree. This is VC. This is what you have taken. This end point. This end point. This will be 45. Right? In this direction, VA cos 45 minus VBX sin 45. So this M2 marks in this direction, this is M3. M2 in this direction, along the length of this string, velocity of M2 will be VA cos 45 minus VBX sin 45 will be equal to VC. This constraint I will have to use. Is this part of the board visible?
Yes, sir. Yes, sir.
Yes, sir.
Yes.
Along with the 3 equations, substitute JB here. I'll have 3 equations. I need this constraint for this string to simplify the problem. And simplification is not very difficult. Don't get frightened with 4 equations. They are quite simple. And 45 degrees, the biggest advantage is whether even if you go wrong with the resolving the vector, cos 45 के बदल में sin 45, sin 45 के बदल में cos 45 ले लो, yet you will get the correct answer. That's the advantage with 45. One second, I'll be back in a minute.
Yes, sir.
Now, 59. There is a car here and this is connected to a wall. You have a peg here, vice versa. This is O. This is M. One second. You're releasing this M from here. So it will have a straight fall till here. This will be the height. Right? He gave you some dimensions. This is 3 meters or something. 3 meters. Length of the string kitna diya hai?
5 meters.
5 meters. That makes your life simple. That means this theta, cos theta is 3 by 5. Cos theta is 3 by 5. Sin theta will be 4 by 5. So you know the height by which 4m. Height will be 4 meters. M is meters given, right? 1 kg of the block. This is 1 kg and string is attached, it fixed release from the position shown. G is 10 meters. Impulse developed in the string when it just becomes taut. When it just becomes taut, have a look at it and draw the free body diagram of this. It was falling with the velocity of under root 2gh. How much is h? 4 meters. Right? It was just before the string became taut, that was the velocity. Just after the string became taut, its velocity will be in this direction and this will be lost. If this is theta, this is 90 minus theta. Resolve them properly. This is theta. This is 90 minus theta. This will be theta. This will be theta. Right? So under root 2gh. This will be under root 2gh sine theta. and this will be under root 2gh cos theta. Because I have taken this as theta, if I have taken this as theta, then this will be cos theta, this will be sin theta. Is that okay with all?
Yes, sir.
Yes, sir.
Yes, sir.
It's only playing with sin and cos, should not be a trouble there. Now, this was the velocity just before the string became taut. After the string became taut, along this length, what will the velocity be?
0.
0.
So now, do I get the impulse due to this t delta t?
Yes, sir.
I have a feeling he asked for this. Impulse developed in the string when it becomes taut, t delta t will be equal to m, capital M or small m, 1 kg into under root 2gh sin theta. This was the impulse t delta t. Now this impulse, if you ask me, you know the impulse in this string. I'll redraw the diagram to keep it clean. Have a look at it. You know the impulse here, t delta t. This impulse will have t delta t cos theta. Should be equal to j here. Do you agree with this?
Yes, sir.
Yes, sir.
Yes, sir.
Where am I? Where am I? Where am I? Okay. Fine. Now where do we stand? What is the third bit? This j will be equal to, this j is equal to 2 t delta t cos theta. Impulse developed in the string PQ is what we have done. Impulse given by the earth at this instant. So we saw t delta t sin theta should be equal to j dash. J dash is equal to this. Is this completely clear to all?
Yes, sir.
Sir.
Fifty-eighth question. Now I have a feeling you should be able to solve all that we did. 58th and 60th May. Only difference is 60th we gave velocity to the point which is different when compared to the one in 58th. 58th is almost similar to 60th. Please have a look and tell me if you're confident of solving or not.
Yes, sir, we can solve.
Yes.
The only difference is 60th you gave an impulse to this. 58 you are giving an impulse to this. It is the same thing in the reverse direction.
Yes, sir. We will.
So I have a doubt. So that T delta T equals to 1 kg into root 2g at sin theta. So wouldn't that be with a negative sign? And also the Nietzsche wala equation.
Both negatives. Have a look
So
at it.
both will have negative signs. So it'll cancel each other out.
Both sides will be negative. Jaldbazi mat karo. Have a look. T delta T in this direction I'll take as positive. So T delta T. Right? In this direction, if I take as negative, final momentum is 0 minus initial momentum is minus under root 2gh sine theta.
Okay,
I
so
took this
understood.
side as positive, this side as negative. So final momentum is 0 minus initial momentum should be negative. So negative of negative positive ho gaya ki nahi?
Yes, understood. Thank you.
Tell me when I can rub the board.
Yes, sir.
Now listen to 157 before I solve. Understand this logic. Suppose there is a car and I give this a velocity of u. Car mass is capital M, mass of the bob is small. Right? Now what happens is, slowly this will start moving to the right. If this starts moving to the right, this tension will pull the cart ahead. Cart also will acquire velocity. This also has some particular velocity. I'll call this V0. What makes you say cart will go ahead? Here, this tension on this. On the cart, the tension will be this way. It will have a horizontal component. So the cart will start moving. When do you think it will go to the maximum height possible? When there is no relative velocity between this and this. Rather, both should be moving with the same velocity. We call it V dash. When cart and bob both are having the same horizontal velocity, that will be the maximum height. Why? Have a look at this. This cart is moving with a velocity v dash. I'm telling you both should have the same velocity, right? If this angle is theta, this angle will be theta. Along the length of the string, v dash cos theta and v dash cos theta should be equal.
Yes, sir.
Right? One way of looking at it using constraints. So when do you think this will stop rising? When both have the same horizontal velocity, the bob will stop rising. Firstly, is this point clear?
Yes, sir. Yes, sir.
In this problem, they did the reverse. They didn't give velocity to the bob, they gave velocity to the car. So technically, bob will remain there and the car is moving ahead. So how will the diagram look like? The bob will be like this. You have given an impulse to the car, right? Cart का mass कितना दिया है? Now whatever it is, immediately after the impulse, velocity of the cart initially I will take as V0. V0 will be impulse divided by M, because mass of the bob is 3M. See the question carefully. And what is I equal to? 2M under root GL by M. 2 under root GL is the velocity which you have given to the car. Impulse divided by M is the velocity. So the velocity you have given to the cart is V. Firstly, is this point clear?
Yes, sir.
This is no big deal. You have given velocity to the cart, not to the bob.
Sir, I have a doubt.
Huh.
Sir, if we give velocity to the bob, sir, you said that the cart will move, right? But sir, once you gave an example that if I switch on a fan on a sailboat, the sailboat won't move. It came in J, you said. Because
Of
it's in
mass, center of mass will not move because of an internal force. But here you gave velocity. Tomorrow you will ask me, I gave velocity of small m and velocity of u. Then why should
yes, sir, got
capital M move? Because center of mass is now moving with you gave a velocity of u. What is VCM? Mu divided by m plus capital M. So center of mass will be moving with constant velocity.
Yes, sir.
Small m and capital M may be interchanging their velocity. It's like on the sailboat, I am walking to the front and back. When I am walking to the front, sailboat velocity will change. When I am walking to the back, sailboat velocity will change. Center of mass will be moving with the same
Speed, or it will be at rest. Yes.
right? Got
Yes.
the point?
Yeah, sir. Thank you.
Sir,
Now it,
sir, still not understood that when they both occupy the same horizontal velocity, how the bob will not move up. Like,
relative velocity of the bob with respect to this has become zero. That's the maximum height.
okay,
When,
sir, understood.
right? If this relative velocity is zero, this VR is zero with respect to bob, it will not go further up. This is relative
Yes, sir.
velocity with respect to this. Maximum height means relative velocity should become zero. So with respect to this point, its relative velocity is zero. That means with respect to this point, both should have the same velocity. Cart has only horizontal velocity. Cart doesn't have vertical velocity.
Yes, sir.
Right? See, I'm standing here. When will I tell you a particle goes to the maximum height? With respect to me, if the relative velocity, the maximum height became
0.
so with respect to the peg, relative velocity should become
0.
peg is moving only in the horizontal direction. So even this bob should be moving in the horizontal direction with the same.
Speed.
Now, in this case, we didn't give the bob velocity, we gave the cart velocity. Cart is given this velocity. Agreed?
Yes, sir.
Yes, sir.
Now, finally, what happens at this particular state? This is 3m and this is m. Both are moving with the same velocity v in the horizontal direction at maximum angular displacement. 3m into v plus m into v is the maximum angular displacement. This should be m into v naught. Initially, you gave velocity only to the car. You are conserving linear momentum in the horizontal direction for both 3m and m put together. Now this will be 4mv is equal to m into v naught. V naught is 2 under root gl. V is equal to under root gl by 2. Right? Great.
Yes, sir.
This is the velocity with which the cart is moving when it reaches the maximum height under root gl by 2. For some reason, I'm not concentrating on the simplification. Keep an eye on the simplification. Now I will conserve energy to get the value of theta naught. How do you conserve energy? R 3m, m and 3m. Final velocity is this 3m v square under root gl by 2 whole square. Initial final velocity is this plus. It rose by how much height? mgl into 1 minus cos theta. You are calling it theta naught. Here I took only m. Why not here? 3m plus m is 4m. Why am I taking 3m? I told you I'm not concentrating. Please pay attention. 3m plus m is 4m. 4m is moving with this combined velocity. This is the final kinetic energy.
Yes, sir.
Yes, sir.
Potential energy rise is only for 3m, not for m. Cart is not rising. Only 3m rises. This is the final kinetic energy. What is the initial kinetic energy? Half m into 2 under root gl whole square. Is this equation correct?
Yes, sir.
Yes. All you have to calculate is theta naught from there. All you have to calculate is theta naught from there. Yes or no?
Yes, sir.
Second part is very tricky. I'll explain why. That's why I explained the last question first. In the last question, what did you tell me? You didn't know the radius, hence you took with respect to center of mass. यही तो बोल रहे थे?
Yes, sir.
Yes.
Yes, sir.
Now, in the second part, if you want the tension, you should know the velocity of this with respect to what?
Here.
The
With
middle
respect
With respect
to
to the peg on the top, right?
Yes,
Yes,
sir.
sir.
And that point is
Fixed.
accelerating.
fix.
The point is,
Accelerate.
so pseudo force.
लगेगा.
लगेगा.
Big back.
समझ में आ रहा है? कितना intricate
sir.
है? If you tell me this is going in a circular radius of length L, that is a math. This point is not at rest. If you tell me this particle is going in a circular track of radius L, that's a math. This point is not at rest. So if I want to take with respect to that point, ले लो मगर that point is not center of mass like the last question. Last question में, why did you take center of mass?
Sir, it doesn't change.
Radius.
It's not accelerating. Why did you take center of mass? I took the velocity of this with respect to center of mass. Center of mass is not.
Accelerating.
Here I will take with respect to this point and tell you radius is L, but that point is.
Accelerating.
You have to take
Pseudo force.
it down till here. I'll explain that. First of all, calculate theta naught and tell me how much answer you are getting. I need that value. You don't do the simplification, I will not go ahead.
So cos theta naught is coming as 1/2.
Yes, sir. Same.
So theta naught is
60 degree.
1/2.
okay. Cos theta naught is 1/2. Theta naught कितना होगा?
60 degree.
60.
Can I rub the lower part of the board?
Yes, sir.
Now listen. What was your logic? Relative velocity of this with respect to the cart should become 0. This is what you told me.
Yes, sir.
Maximum height per kya hoga? Relative velocity of this with respect to the cart is 0. That means with respect to this, velocity is 0. That means centripetal acceleration will be 0.
Yes,
mv
sir.
square by r. mv square by r, velocity of this with respect to this is 0 means centripetal acceleration will be 0. Yes or no?
Yes, sir.
Yes, sir.
But to calculate with respect to this, I will have to take a pseudo force. Cart will have, you gave a velocity in this direction and the velocity is slowing down. That means cart has an acceleration in the backward direction. Yes or no?
Yes, sir.
Yes.
Yes.
So pseudo force of m a naught and mg on this. Sorry, ये 3m है ना यार. 3m a naught, 3m a naught and 3mg are in this direction. Firstly, is this clear to all?
Yes, sir.
ये pseudo force ध्यान से देखिए. Cart has been given a velocity this way and its velocity is decreasing. क्यों भाई साहब? How did you decide that it is decreasing? Some part of the kinetic energy is going into the bob. So velocity of the cart should decrease. So that means cart is decelerating in this direction. Matlab accelerating in backward direction.
But
Cart is accelerating this way. Pseudo force on this should be in this direction. Pseudo force क्यों ले रहे हो आप? I am
Accelerating
solving the problem with respect to the peg. And centripetal acceleration calculate करने की जरूरत है ही नहीं. मुझे radius चाहिए ही नहीं. Because VR is 0. mvr square by L. L is not a concern anymore for me because VR is becoming 0. But with respect to this one, pseudo force must be taken. Right? Now, have a look at this. In this direction, this angle will be 30 and this angle will be 60. Am I right?
Yes, sir.
Now, centripetal acceleration, you are telling me is 0. Why? Relative velocity is 0. Why? Only then it will be at the maximum height. You calculated 60 degree when relative velocity of this with respect to the peg of the cart is 0. So 3m a naught cos 30 is equal to 3mg cos 60. Along this direction, centripetal acceleration is 0. How much will I get a naught as? Will I get g by root 3?
Yes, sir.
This is t. T sin 60 is equal to m into a naught. A naught यहाँ substitute करोगे तो t आ जाएगा कि नहीं?
So can you repeat the logic behind 3m a naught cos 30 equal to 3mg cos 60?
Centripetal acceleration should be 0. Radial acceleration at maximum deflection should become 0, right?
Is the answer for this question given wrong?
How much is the answer? How much are you
2 mg
getting?
by root 3.
How much?
So I'm getting 2 mg by 3, but the answer is given 2 mg by root 3.
No, 2 mg by 3 is the answer. 2 mg by 3 is the answer. There is a misprint there.
The answer is 2 mg by 3 only.
2 mg by 3.
Yeah.
तो रूट 3 क्यों बोल रहा है वो बंदा?
वो पीछे दिया है.
सर पीछे √3 दिया है.
Oh, yes, sir.
हाँ.
Now 56. One second. Let me see this. 56. 3 blocks on a billiard table. On a billiard table. Wonderful. 56 actually is an easy problem. ध्यान से देखो. This is U. This is A. This is B. This is C. Right?
Elastic college.
What will this angle be?
30 degrees.
30 degrees.
30 degree.
He tells you in the start that A hits B first. Within a fraction of a second hits ball C. A will first hit B. So what will be the scenario here for us? This component is transferred to B, right? I am left with only this component. If this was U, this angle is also 30. This will be U cos 30. And this is transferred to B, that goes straight. I am assuming this is going with U cos 30, right? This is also U cos 30. This will collide with C. Firstly, till here, are we sure and clear?
Yes. Yes.
But what is the velocity if this is U cos 30? If this angle is 30, have a look at it. What will be the velocity of U cos 60 will be the velocity of B of A just after collision, because this is U cos 30. So velocity in this direction will be U sin 30 or cos 60. So this is the velocity of A just before it strikes B. This whole angle is 60, this angle is 30. This are you people able to visualize?
Yes, sir.
Yes, sir.
When A strikes with B, U cos 30 went to it and that's gone. U sin 30 or U cos 60 will be left over with A. Now your problem is altogether new. What is your problem here? The angle between this angle is 30°, right? And this is the velocity u. This will be cos 60. This is the velocity. What will this angle be? 30°. So this velocity u along this direction I will resolve. This will become u cos 60 cos 30 will be transferred to this, and this u ka perpendicular component, this angle will be 60, u cos 60 sin 30 will be left over with this particular body.
Yes, sir.
Say something. Did you understand what I did? Is playing with geometry. I repeat, this moving with the velocity of u. This will transfer u cos 30 to b. B will move. What is left over is u sin 30 or u cos 60, which is not along the line joining the centers. Which is not along the line joining the centers.
Yes, sir, got it.
Now this I will have to resolve. This u cos 60, I'll have to resolve along the line joining their centers. Right? Why did you draw this line in the first place? Don't. This angle will be 60. This is u cos 60. Along the line joining their centers, u cos 60 cos 30. And this will be the perpendicular component left over with this. This is moving with u cos 30. This will be moving, this is C, will be moving with this velocity that will be imparted. This body will be left with this velocity in this direction. Now you know for sure what is the angle. 60 plus 30 plus 30. 120 degrees will be the angle by which it will be deflected, the particle. Purely playing with playground.
Yes, sir. सर ये क्वेश्चन में सर सब ट्राई कर लिया.
कौन सा क्वेश्चन?
सर 55th. सर जिधर मोमेंटम कंजर्व नहीं करना उधर भी कर, मतलब इतना मतलब फ्रस्ट्रेट हो गया था.
During the collision, the horizontal velocity does not change. This you are calling as A and B.
Yes, sir.
This you're calling as C and D, right? During the collision, first point, horizontal velocity doesn't change. Do you all agree with this?
Yes, sir.
So, second point, it travels equal distances in equal intervals of time. Equal intervals of time. Second point, is it clear? Horizontal distance. Equal horizontal distance in equal intervals of time. Do you agree with this?
Yes, sir.
So implies time of flight between two collisions is the same. Implies time of flight between two collisions is same. क्यों भाई साहब?
Distance same है.
Every time it hits the center of this particular step. So horizontal distance. See, it travels equal horizontal distance in equal intervals of time. So time of flight for every collision will be same because horizontal distance x is vx into time of flight. Horizontal direction there is no acceleration. और आप क्या बोल रहे हो अभी? Every time it will hit the center of the step बोल रहे हो. That means every time it collides, it is traveling by equal horizontal distance. Yes or no?
Yes.
Yes, sir.
So x is the same. Rather horizontal distance, I'll call it s. S is x by 2, x by 2. X by 2, x by 2. Agreed?
Yes, sir. Yes.
And then you are telling me S is the same, Vx will be the same. So time of flight should be the same.
Yes.
Yes.
Yes, sir.
And what is the formula for time of flight?
2u sin theta by
Uy by g. If Uy is the same, maximum height to which it goes should be the same.
सर ये चीटिंग है.
Awesome proof, right? मैंने
Yes,
कुछ भी
sir.
सॉल्व नहीं किया, फर्स्ट बिट सॉल्व कर दिया. आपने
हाँ,
क्या
sir.
बोला? हर अटेम्प्ट कर दिया आपने. You attempted everything that you know. Common sense is not very common among people. इस क्वेश्चन सॉल्व करने के लिए फिजिक्स की नहीं, कॉमन सेंस की जरूरत है.
सर
ये सेडिज्म हो गया.
सर इधर
बहुत
मोमेंटम
फाइट मारते हैं बच्चे इसके लिए, बहुत फाइट मारते हैं. हर साल देखा है. Generally, we don't give you this at this stage. This question we gave for your seniors in their revision lecture. सिलेबस होने के बाद तभी भी फाइट मारे थे बच्चों ने. अब सेकेंड ईयर होने के बाद बच्चे बड़े कॉन्फिडेंट हो जाते. If they are unable to solve, they assume question is wrong. सर क्वेश्चन गलत है सर, हो नहीं सकते सर. I calculated the general equation of the projectile and I proved that it will not fall at h by 2. यार, you are investing your energy to prove that the question is wrong. हद हो गई. I repeat the logic, ध्यान से सुनिए. All that I used from collision is horizontal velocity after the collision will not change. Agreed?
Yes, sir.
Yes, sir.
During the projectile, horizontal velocity will it change? It doesn't. So Vx remains the same all throughout. और आप बता रहे हो every time this is x by 2, this is x by 2, this is x by 2, this is x by 2. Every time it collides, it covers same distance बोल रहे हो. So time of flight is the same. तो क्या हासिल कर दिया यार तुमने? Time of flight अगर same है, the maximum height to which it goes will always be the same.
Yes.
बात खत्म. First bit is over. Yeah.
So now we'll assume that angle to be beta and then use E is equal to tan theta by tan beta. And...
Now everybody will be ready to attempt. Please do attempt. I'll be more than happy.
नहीं अभी हो जाएगा अभी.
सिंप्लीफिकेशन थोड़ा गंदा है. अभी हो जाएगा मगर सिंप्लीफिकेशन गंदा है सेकंड बिट का. I'll give you people time. I'll discuss the second half in the next class. I'm okay with it. Now that you have an idea, Now solve for the second bit, but I'll give you time. Not now in the class, do it later on.
ये सर ये सच्ची में एक्सपेक्ट नहीं किया था ये.
Right? You thought problem is very lengthy. Even now you're being duped. Second bit, your thinking is easy. It is easy, but it is lengthy. First bit you thought was very lengthy. It's easy. Second bit, now your thinking is easy, but it will be very lengthy. Quadratic equation आएगा, simplification गंदा रहेगा. मगर go through the pain. Technical ragging. हमारा भी बनता है. इंडियाना जोन्स पिक्चर देखा है कभी आप लोगों ने?
हाँ सर, थोड़ा थोड़ा
देख लो, one of the masterpieces of its times. There are few movies which you shouldn't miss. One is Indiana Jones. Indiana Jones Part 2, Part 3 भी आ गया. I don't remember the stories, but Indiana Jones Part 1, first part I have seen in my childhood. Every scene I remember. I saw that twice if I'm right. Guns of Navron.
Guns of, sorry?
Navron. Guns of Navron. Abhi Guns of Navron is on Netflix. You can see that. Navron. Awesome movie. Guns of Navron, right? In Indiana Jones, there will be a very beautiful scene. One huge guy, he will remove two swords and he'll keep turning back to the hero of the movie is running to save the heroine because they are in search of a huge gold mine. Tons and tons, even sand is like gold there. Right? Now there is a specific map to reach there, and the whole of the movie is about trying to reach that particular point using a map which is in several pieces. That's the concept of the movie. In one scene, the heroine is caught and she is kidnapped, and people in the Arab country are in pure Arab dress. They put up a burqa so he cannot recognize her. He is desperately searching where she is and is running. Now, the movie direction is so good that you will be engrossed. You will be in a hurry sitting in the theater, says to search where the heroine is because she has the other part of the map. She will become the guy. A huge guy with two big swords will start rotating the swords and he will stand in front of the hero at some distance. Whole of the crowd will stop and they're watching. And the hero is least bothered about seeing that guy. You think there some confusion. This guy is not observing him. Suddenly the hero turns towards this guy, picks up a pistol, shoots him and runs away. The speciality of that scene is the moment in a very huge, serious scene, everybody in the theater will laugh. You are expecting something, a big fight between the two. He'll just remove a pistol, he'll shoot and he'll walk away. And that guy is a huge guy with two swords. No, the pistol is not, director itna dhyan se movie nikala, he makes sure that we don't observe the pistol with the hero.
Yes, sir.
Now you know why I told you this story.
Yes, sir.
Most obvious solution.
Yes, sir, समझा.
Sir, have you seen Interstellar?
I have seen one of your senior batch, or you people only told me that. After that I saw.
So you understood it?
सर मुझे तो समझा ही नहीं मूवी, मुझे और एक बार देखना पड़ेगा.
सुनो, उससे पहले उसको वो पिक्चर समझने के लिए ग्रेविटी पिक्चर देखो.
ग्रेविटी देखा मैंने.
सर ग्रेविटी स्कूल में दिखाया था.
बाद इंटरस्टेलर देखो तब समझ. When I told about gravity while teaching the chapter gravitation, when I referred to your senior batch about this, they told me, sir, Interstellar देखो. Then I saw that. I didn't know that before. Can I rub the board?
Yes, sir.
Yes.
Yes.
The B bit is pending. You will solve. If you don't get, I will solve in the next class. This is very tiring here. Since morning I'm taking these doubts. Now listen. For the next bit, I'll give you a hint. I expect you people to solve.
But ये की problem से मतलब similar है ना, E की power है.
It strikes with the velocity of u, it will rise up with e to the power u. After the nth collision, it will rise up with a velocity of e to the power nu. You're right. जिसने भी बोला है. Now your condition is after the nth collision, the kinetic energy should be such that it should come only till this particular height. Hint समझ में आया? After the nth collision, it will strike with the velocity and it will rise up with the velocity e to the power nu. Yes or no?
Yes.
Yes.
Yes,
This
sir.
kinetic energy should be just sufficient or lesser than the required for it to reach this particular height. Now, यहाँ पर देख लो एक बार. Suppose I get number of collisions to be 3.8.
4.
For it to reach this particular point. 3.8 for it to reach this particular point. You ask me what is the minimum number of collisions so that it doesn't cross this point. Means I will say
4.
4. Right? After 3.8, 3.8 doesn't make sense. That means after the third collision, I will have energy to cross this point. Yes or no?
Yes, sir.
Yes.
Now students misinterpret one thing. So my answer will be 4 means what students tell me is, sir, either way 3.8 we will round off to 4 no yaar. थप्पड़ मारूंगा. अगर 3.4 आ गया तो minimum number of bounces after which it will not cross this point will be
4. 4.
because after the third collision it will again cross this particular point. So minimum number of collisions for it to not occur. It is not about rounding off. It is not about rounding off. If I get 3.8, 3.4 or for that instance even 3.1, that means after the third collision, I will have surplus energy to cross this particular point. Yes or no?
Yes,
Yes.
sir.
So he is asking minimum number for which it will not cross this particular point. That means whether you get 3.8, 3.4 or 3.1, answer will be.
4.
4. 4.
Is the logic clear in this?
Yes, sir.
Yes.
Now students tell me we will round off. Rounding off does not make sense here. He's asking minimum number. ऊपर से minimum तो 3 होगा ना sir. 3 is lesser than 4. Question to देख लो बोल रहा है you should not cross this point. In this case when you are equating this energy to rise to the height, if you are getting 3 point something, that means you are crossing this particular point, right? After the third collision.
Yes, sir.
I will stop here. I know there are only a few more left over. I'll complete it in the next class. And then in the next class, after completing this, I'll start the booklet.
Okay,
Booklet
sir.
discussion, if you want, I'll start it from exercise 4. If not from exercise 7.
Exercise 2 will be better.
Exercise 2.
Exercise 1 is done. So 4 is also tough, so it's taking time to solve.
It will take time. That's
Yes,
right.
sir.
Either way, you keep me informed. Major test may you have got only up to center of mass. You don't
Okay,
have
sir.
collisions, conservation of momentum, spring masses, no. So, but doesn't mean you will keep everything pending.
Yes, sir.
Please do complete, give little bit of a time and complete this. Undoubtedly from Monday, you will start preparing for your major test.
Yes, sir.
Yes,
Yes.
sir.
Before Monday, try to finish off. I'll discuss the doubts fully. I'll go slow. I'll not start rotation before your
Thank
major.
you, sir.
Thank you.
And
Sir,
you
I have a
people
doubt.
will have 1 day of a holiday after your major test
Thank
as
you, sir.
asked.
Thank you.
Yes. Thank you, sir.
So can you send today's recording?
Yes,
Thank you, sir.
Thank
I
you.
will.
Sir,
Bye, sir. Thank
Sir, I have a
tomorrow's
doubt.
test only COM partner, no
Only
collision.
C1. Only C1.
Okay, sir.
Sir, I
Thank
had a
you.
And so
conceptual
today
doubt.
Hello.
Sir, at collision, the non-impulsive friction will become impulsive, and after the friction, after the collision is over, it will again become non-impulsive.
Naturally.
Okay, sir.
Because the
Sir,
impulsive force will exist for a short time interval.
Sir, So when we are doing questions on projectile on an incline, so can we take incline to be horizontal, and then we apply rotation of coordinate system? So like we get a height considering the plane to be horizontal, and then we apply rotation of axis, which is
एक ही दिक्कत है उसमें, normal horizontal plane में the velocity parallel to the ground is constant.
yes sir. हाँ उसमें अलग
Inclined plane में velocity parallel to the incline which you took as x-axis will not remain constant.
Sir, means he's saying without using the remembering the formula, we can take one as x-axis and one as y-axis and then solve individual.
Right, no issue with.
Okay, so we
It's
can't
also
apply.
on an inclined plane, na?
Yes sir. So we can't apply rotation of axis, right?
Take this velocity down the inclined plane increasing, then you'll get the correct answer.
Okay sir, got it. Thank you.
So today's test time window is 6 to 9, right?
Yeah. The window will be open from 6 to 9.
Okay.
Good day. Bye.
The difficulty level of
Right,
physics.
sir.